Hi everyone! Welcome back to another planetarium live stream. My name is Jessica. I am the planetarium director, and with me today I've got two, which should be pretty familiar faces, two of the planetarium students here helping me out, and I will let them introduce themselves, starting with, we'll go Lindsay, since she is to my left tonight.
Hi, I'm Lindsay. I'm a physics graduate student at UMD.
Hi, I'm Eli. I'm a physics and astronomy undergraduate at UMD.
So tonight we are doing Ask an Astronomer. So whatever questions you have about anything pertaining to the universe, type them down in the comments. We will be watching that. We also have a few things to kind of talk about until we get some questions coming in, some interesting kind of like current events and things that are going on. And so I'm going to let Eli take it off, or take it to start with, because I think that his topic is probably one of the most questions that we might get or that people might be interested in, and he's going to be talking about the new comet that we can see up in the sky. So I will let him take it over.
Alrighty, I'm just gonna make sure I get the right view up. Okay, are we looking good?
Yep.
Okay, cool. All right, so we're going to talk about Comet Neowise for a bit. Comet Neowise was discovered earlier this year by a NASA telescope called Neowise. That's why it has that name. And although Neowise is actually starting to get just a bit dimmer every night, it was its brightest on July 3rd, I believe, was the night. There's still plenty of time to spot it in the evening sky now. Earlier, we were looking in the really, really early morning sky, but it's gotten pushed back. So you can actually look for it after sunset now is about the best time to see it. So for northern hemisphere observers, and that only northern hemisphere, you can't see it from the southern hemisphere. The comet is now most visible about 45 minutes after sunset. So this is an accurate star map for tonight, but unfortunately, if you're in the Duluth Superior area, you probably won't see much of this at all. We're supposed to get some pretty nasty weather, but you know, if you're down in the cities or anywhere surrounding that doesn't have bad weather, you'll see a sky that looks more or less like this. So this is the sky at 11 p.m. and tonight, Neowise can be found right next to the front foot of Ursa Major. So that's what I've put in the red circle on the left-hand side of the screen. And as the days go on, it will move up and to the left through the nighttime sky. So tomorrow, it's going to be in between Ursa Major's feet, and then the next day it'll be by his back foot. So I would recommend trying to spot Neowise within the next 2 weeks or so, because after that, we're going to have a full moon kind of nearby in the sky, or you know, a large moon for time surrounding it, and it'll make it kind of hard to see stuff in that general area. It's going to drown out a lot of the stars and the comet. So you're going to want to try to spot it in between then, because after that full moon phase, that large moon gets out of the way, Neowise is going to be really close to the horizon and eventually under the horizon. So these last 2 weeks are kind of the crunch time to see it. So right now, Neowise has an apparent magnitude of just under 6, which is just really barely scraping what the naked eye can see, but it's actually just close enough to that threshold that if you're in a highly populated area like Duluth is with a lot of light pollution, you might not actually be able to see it naked eye at all. So if you're in Duluth or the Superior area, we do deal with a fair amount of light pollution. So I'd recommend grabbing a pair of binoculars or even a small telescope. And you'd be able to see Neowise pretty well, I think. So I'm just going to move on to the next slide here.
So I have a question, actually. I just
Yeah.
remembered that I got a phone call the other day with a question for, and I don't know if you have this planned for a little bit, for good viewing areas in Duluth, particularly since we have the big hill and Neowise is a little bit closer to the horizon. Do either you or Lindsay know if like Brighton Beach would be okay?
Mm-hmm. The My favorite place to go personally is Hawks Ridge, just because I feel like when you're up there, you're kind of above most of the city light that's down below. But I know Lindsay is partial to Brighton Beach. I've actually never been, but I would defer to Lindsay in that situation. I know she says viewing there is pretty good.
Fox Ridge is one of my favorites also. And then, yeah, Brighton Beach, as long as you are looking kind of to the north or over the lake, you know, and what you're trying to look at isn't back over where the city is.
Hmm. And then actually just recently, I discovered a kind of a new favorite spot of mine. I don't know how much anybody is willing to drive, but down by Jay Cook State Park, from what I've seen there, there's not a lot around there, so you'd probably get some pretty good viewing there. And the park is really pretty, but I guess I don't know exactly when state parks close or not. I would assume if they're open for camping, you can be there late at night, but I don't know for sure. But I would also try that. It's about, I'd say, 20 minutes south of Duluth, maybe somewhere around there. And that area is really pretty. So I would recommend that too if you're also wanting to just walk around and check out the park. But yeah, pretty much anywhere. I like Hawks Ridge a lot too because it's pretty close, not that far of a drive, maybe 10 minutes. And Yeah, the last time I went to Hawks Ridge, I was looking for the Northern Lights, and I think I saw a little bit of them, which is pretty impressive for somewhere like Duluth. So yeah, Hawks Ridge is good. Brighton Beach, like Lindsay says. But yeah, so okay, if you were to get binoculars, or in the case of this picture, a really good telescope to look at a comet, you'd see some really interesting stuff. So most comets, I should say, and Neowise certainly included, can be kind of like classified in three different parts. So you have the head of the comet, which is called the coma, which contains the nucleus, which is the solid part of the comet. And this coma, once it enters like the inner solar system, solar radiation pressure and pretty much just light coming off of the sun will start to vaporize materials that are on the surface of the nucleus. And it'll start pushing dust and some gas off of the comet. And this is what makes it, what we actually see like with the tail behind it, not just a kind of a little spot. So before the coma, or the nucleus enters the inner solar system, they're actually really hard to spot because there's nothing on them that gives off a ton of light, and they're really, really far out, way far out from the center of the solar system. So they're extremely hard to spot, actually. And they're really big, but in the grand scheme of things, like not nearly as big as like planets and stuff like that. So really hard to spot, really far away. But once they get into the inner solar system, like I said, usually this is classified as about 3 to 4 astronomical units, so 3 to 4 times the distance from the Earth to the Sun. That radiation does start vaporizing stuff on the surface, and then it creates what we actually see as the comet. So this dust that gets pushed off by this radiation pressure makes one tail of the comet, which is called the dust tail. And the gravity of the sun combines with that radiation pressure, and it makes like a little curved tail that comes off the comet. And I have a diagram in the next slide that will show exactly what this looks like. But then also gases that come off, a lot of water comes off, and other hydrogen compounds, they get vaporized and they get split apart into smaller things, and that forms the ion tail. So these really light gases get pushed almost directly in the opposite direction of the sun because of that radiation pressure. And I actually also just learned today that they also are influenced by the sun's magnetic field, which is a factor in pushing them directly away as well. Maybe I'd heard that before, but it didn't stick in there.
Yeah. It's also why
So
the ion tail can be kind of have some like structure to it, some like wisps and waves and stuff,
mhm,
because it's being influenced by
right,
the magnetic field, but the dust tail isn't. That's why it tends to appear much smoother.
with that arch shape. Yeah, that's really cool. So yeah, and then in this next slide that I have here, it kind of shows um, the anatomy of that. So as you can see, the gas tail or the ion tail is always pointing almost directly away from the sun, while the dust tail kind of follows this curved path because it's also being influenced by the sun's gravity, and its momentum in the direction it's traveling has a factor. So it follows this kind of curved path that's indicative of an orbit. So Neowise currently is at the kind of orange star that I made on the white line in the orbital path. It just passed when it was closest to the sun. So now it's going to start working its way into the outer solar system again, which is going to take a long while. But it's going to be really, really easily visible to us for the next 2 weeks. And you're going to want to catch it in these next 2 weeks because after it becomes invisible in this orbit, you're going to have to wait. I think the number is about 6,800 years until it comes around again. So it's going to be quite a while. So yeah, that's a bunch of information about Neowise. I would recommend trying to find it. I was going to try to find it tonight, but if you look out your window, you can see why I'm thinking I might stay inside. So I'll have to go out another night. I was thinking tomorrow, but we'll see how the weather turns out. So yeah, right. Passing it off.
Awesome. All right, so again, if you have any questions for us, let us know in the comments. And until then, I will hand it over to Lindsay, who has got our next topic.
All right, hello everybody. Let me get my screen shared with you. I'm going to be talking about a new mission that is going to be traveling to an asteroid. Specifically the asteroid called Psyche. So we already know that it's made primarily of nickel and iron, and that is also mostly what the Earth's core is made up of. And that's also where the Earth's magnetic field comes from. The iron and nickel moving around in Earth's core creates our magnetic field. So one thing that they're really curious to find out is if this asteroid has a magnetic field like the Earth, since it has the same types of things in it that our core does. Another thing that they are going to be looking into is, if this could potentially, way in the future, be an asteroid that we could mine for, nickel and iron. So you can see that it is kind of in the outer part of the asteroid belt. That's between the Mars and Jupiter. And one possibility for how it formed could be that it actually maybe used to be the core of a planet. So because it has the same composition as the Earth's core, it could have been the core of a different planet, but then maybe the outside of that planet got stripped away. And so all that's left is the core and the nickel and the iron from the core. So this is a closer up of the spacecraft that is going to be traveling to Psyche. So the Jet Propulsion Laboratory is planning on having most of the instruments ready for testing by February 2021, with everything done with testing by April 2021. And then hopefully it will be launched soon after that. Some of the things that it's going to be measuring, again, is it's going to have a magnetometer on it to measure any potential magnetic field. It's going to have ways to collect data about the composition and the topography of the asteroid, again, to see if it could potentially be a place where we could mine later on. This is an this is an artist rendering of what we think this asteroid looks like. Now, asteroids are really small, so unless you can get really close to them with spacecraft, you can't really tell what they look like because they're just too small. So when we finally get to this asteroid, then we will finally be able to see exactly what it looks like. So it is going to launch from Earth in August 2022. That's when it's planned anyway. So it's going to get launched. It's going to start along this pathway. It's going to go by Mars and get a gravity assist. So as it goes by Mars, the gravity of Mars is going to kind of pull on the spacecraft a little bit and adjust its path until it finally arrives at the asteroid in January 2026. It's going to be orbiting the asteroid for 21 months, and then the end of its mission is going to be October 2027. I'm not sure what's going to happen with it after that. Many of the recent asteroid missions have started out planning on only visiting one asteroid, but then after that, if it's really successful, they might look to see, and the spacecraft is still working well, they might look to see if they could find, or if they might be able to send the spacecraft off to another asteroid before it comes back to Earth.
So is this one planning on coming back to Earth? Or
I think they don't know.
okay, because I know one of the other common. Go ahead.
Mm-hmm. See if it happens to end up be by any other asteroids that it could visit at the end of its mission.
Because I know another common thing is to what was the way they put it? It's not intentionally crash, but they have a nicer way of saying
Right.
landing on the asteroid. I know that happened with the one that went to Eris.
Oh, okay. And Cassini.
Yep, Cassini did the same thing.
All right. Now we are going to pass it off to Jessica.
My turn. All right. So let me get switched over. So the first thing I was going to talk about, we just got some news on the James Webb Space Telescope. For I don't know how many years now, I keep hearing it's going to be launching soon, but it looks like the time is maybe finally actually coming. So the telescope is fully assembled and is going through its final tests right now. And the launch date has been pushed back a little bit. It was initially set, or the most latest launch date was March 2021. But because of the pandemic and everything having to kind of close down, testing and moving forward with that has slowed a bit. And so they're now aiming for October 31st, 2021, which I think is just awesome that we might launch on Halloween Day. And so here we have a picture of the telescope. It's kind of folded up. This is a really interesting design because, let me pull it up. It's such a large telescope that we can't launch it kind of fully as is. What we have to do is fold it up so that it fits better into a spacecraft. And then once it gets into position, it's going to unfurl itself and become what we see here. And that's interesting and also kind of scary because, obviously we want things to go well, which is why they're testing the systems so much to make sure that everything will go well as it unfurls itself. But I know myself and many other astronomers are incredibly excited about this telescope. It is going to be going on, it's not going to be orbiting around the Earth, it's actually going to be orbiting around the Sun, which puts it pretty far away from the Earth and makes it inaccessible to us. So unlike the Hubble Space Telescope, where we had missions that went out to service it and fix things when they went wrong, we can't do that with the James Webb. But we're putting it out that far because we need to get away from the Earth, because James Webb is going to be looking at infrared light. And you can think of infrared light as kind of the heat that you feel when you stand close to a fire or when you're out in the sunshine. We sense infrared as heat. And the Earth itself is hot and glows in the infrared. And so we need to kind of put it away. That's also what that silver thing there is. It's a shield to block the Earth's and the sun's infrared light so that it doesn't give us a false signal. But the reason we're doing this is because looking in infrared light is going to let us see some of the very first galaxies that ever formed in the universe. And this is going to tell us so much about what happened at the very beginning and how galaxies got started, what the first stars were like, because we have a lot of questions still in exactly how that started out. And as someone who did my grad school research on galaxies and galaxy evolution, I am incredibly excited for this. Some of the other things it's going to be able to detect are planets around other stars because they glow in the infrared. And so that can help us in our search for planets and getting some actual images of planets instead of the more indirect evidence that we have now. So yeah, it's very exciting, and I am going to be super happy once it does finally launch. I know I can't wait to see what all we learn from it. And the other thing that's recently happened is the New Horizons mission had its 5-year anniversary. So New Horizons is a spacecraft that was launched to fly past Pluto and give us our first and only really up-close detailed view of this little dwarf planet. It flew past in July of 2015, so 5 years ago. And since that happened, we have learned a lot. We've also learned that there are a lot more questions about Pluto than we thought. We initially thought because Pluto is very small, it's about 60% the size of our moon. It's very small. We knew it was made of ice. We thought it was just this kind of lump of ice floating far away from the sun that didn't really have a lot of interest or a lot of things going on. But if you look at the picture here, you can see that it's kind of complex. There's a lot of different, and let me pull in a little bit bigger one of just Pluto. There's a lot of different kind of textures and colors. There's a lot of variation in the surface. We have this really smooth area that's shaped kind of like a heart. It's the heart on Pluto. And the fact that it's smooth was a huge shock to us because surfaces are smooth when they've had recent activity. Because, most things have craters. Things that have been around for billions of years that the solar system has existed have been hit by things. And so you have lots and lots of craters on these solid surfaces. It's only on worlds that have some sort of geologic activity, like the Earth, we have volcanoes, we have plate tectonics, wind and water erosion. We have all sorts of things like that that actually erase the craters that happen and make the surfaces look smoother, very much like, filling in a pothole in a road. And so we expected Pluto to be just heavily cratered because we didn't expect it to have any sort of activity. And it turns out that that is not the case. Not only does it have activity, the fact that these surfaces are so smooth tell us that Pluto has had some recent, which recent in astronomy means like, a couple 100,000 years, but still some recent activity, which is not what we expected. And so if anything, it's taught us that there is a lot more going on in these small icy worlds, which makes us question how much we know about these small icy worlds that are moons around the giant planets. And so it's really just opened a lot more avenues and showed us that there is a lot that we don't know. So back to the first picture I showed, next to Pluto there is its largest moon, Charon. Pluto actually has a total of 5 moons. The other 4 are much, much smaller. They're Styx, Nix, Kerberos, and Hydra. Got a whole underworld theme here since Pluto is, the god of the underworld. One of my favorite things, though, is that dark patch kind of on the top of Charon is named Mordor because, sci-fi nerds are in a lot of astronomy. The other thing that's happened since New Horizons passed Pluto, like Lindsay was saying before, a lot of times we plan missions for one particular target and then pick others afterwards. And that's what happened with New Horizons as well. It flew past another object out past Neptune in this region we call the Kuiper Belt. And it flew past Arrokoth, which you can see here. And so this is our first kind of up-close view of another Kuiper Belt object. And New Horizons is continuing to make its way through the Kuiper Belt, taking images of what it can, and will just keep doing science for as long as it has power and as long as it's able to send information back to us, which can be a good long while. Because we have things like the Voyager spacecrafts that were launched in the 80s, and we are still receiving signals from as they are traveling really far away. They're starting to actually exit what the influence of the sun, so exit the whole solar system. And so, yeah, as long as they have power and can communicate to us, there's a lot that we can still learn from them. And it's going to be exciting watching what we learn from this. And as we continue to analyze all of the data it sent us back about New Horizons and Arrokoth, because there's still a lot to go through and a lot to try and interpret. And hopefully these new questions means we'll get some new missions going out there. I may be particularly biased since I love Pluto. I grew up with it being my favorite planet, and I guess now it's my favorite dwarf planet. But I love it and love that it's finally getting the attention it deserves. So yeah. All right. Well, that's all I have. And I'm not seeing any questions coming in. So,
I have a question.
Okay.
Do you know what the plans are for the Hubble Space Telescope after the James Webb ends up in space?
I'm pretty sure they're going to let it just deorbit. Yeah.
That's going to be a bad day.
It is going to be a very sad day. And I will say, deorbit sounds a little scary, but they're going to do it carefully so that it lands in the ocean and not, near any populations. They can do a very controlled deorbit. But yeah, I'm pretty sure that's the plan. Hopefully, they'll do a safe deorbit so that maybe we can still have pieces of it to display. Instead of a lot of satellite deorbits are designed so that the satellite pretty much burns up in the atmosphere as it comes back in. But maybe they won't do that, so we'll have some of it, because that would be really cool. But yeah, that's going to be sad. I still remember Cassini. That was a sad day, too.
Mm-hmm. Pretty sure I have that day nailed into my head just because I remember it. It was, I think, I might have the day wrong, but it was September 16th, 2017, I think was the day. Actually, I'm going to double check that.
I remember, so New Horizons, or no, let me go in order of the dates I remember. Curiosity safely landing on Mars is a day I will never forget. I stayed up super late to watch that. New Horizons flying past is a date I will never forget, because that first press conference with those first photos, when everyone was just like, oh my god, this is nothing like we expected. Like, it was so crazy. And then, yeah, Cassini. I'll also remember, and this is me being a little mushy, I'll remember Juno successfully entering orbit around Jupiter, because that's the first time I talked to my fiance was that day. So that one's also one I'll remember for maybe slightly different reasons, but yeah. Were you right?
I was 2 days off, September 14th.
So close.
So close.
All right. Alrighty. Well, I'm not seeing any questions. We are coming up on half an hour, so let's see. Next week, we have on Wednesday, we're doing a tour of the solar system, which is going to be a lot of fun. And then next Saturday, we're going to do a show all about the zodiac. kind of tell you what it's supposed, like its scientific meaning behind these zodiac constellations, how they've changed over time, and that sort of stuff. Explore kind of everything behind that. Um, so, thank you all for joining us. We hope you have a wonderful rest of your weekend. If you want to rewatch or watch any streams that you've missed in the past, you can find them on our YouTube channel or in the video section of our Facebook page. So thanks again. We hope to see you next time and have a wonderful rest of your weekend. So bye, everyone.